Took us through questions 1 through 5. Part 2 is going to start off with the Descartes rule of signs, question number 6. So let's go back to our whiteboard, add a new slide. You can't see it, but I'm moving the screen recording little notation out of the way. So I'm not just drawing random black lines. All right, the Descartes rule of signs, all this is asking us to do is to find the possible number of solutions. It's not asking for the actual solutions. It just wants to know, of my solutions, what could I possibly have? Could I have positive numbers? Am I going to have negative numbers? Am I going to have imaginary numbers? If I know beforehand a rough idea of what my solutions look like, I get a better idea of what that graph is going to look like. Step 1 is I need to first find the changes in the signs for positive x. This will tell me the biggest number of solutions for positive solutions, and then I just count down by 2. So looking at our changes, I'm just comparing the coefficients. So positive 1 to positive 3, no change. Positive 3 to negative 2, that's a change. Negative 2 to negative 1, no change. Negative 1 to positive 10, that's a change. So what this tells me is that for positive x, all right, I had 2 sign changes. So my solutions for this function, this quartic function, I could have 2 positive real solutions, or I could have 0 positive real solutions. Now, if I want to check of those 4 solutions I'm going to have at the end, how many of them could be negative, I'm going to try negative x. What I first have to do is substitute in that negative x into our function, and then we're going to simplify using our rules of exponents, a little bit of logic to get what the new function simplifies to, and then check the signs. So a negative base to an even exponent, I'm still going to have a positive answer. A negative base to an odd exponent, I'm going to have a negative answer. So I want the opposite of this. Negative base to an even exponent means I still have the same answer. I'm not changing anything. This is positive, but that's negative, so it stays negative. And then a negative x times negative 1 becomes positive 1x. There's an exponent of 1, the ninja 1, so that's why this whole thing is negative. And then we have positive 10. So checking our sign changes now. Positive to negative, that's a sign change. Negative to negative, not a sign change. Negative to positive, that's a sign change. Positive to positive, not a sign change. So what this shows me is that now, for my solutions, I could have 2 negative solutions because of these 2 sign changes, or I could have 0 negative solutions. So now what I'm going to concern myself with is what does this look like for the rest of my solutions, for my imaginary solutions. So let's go ahead and take a look at our chart. So I have my positives, I have my negatives, I have my imaginaries, and then everything needs to equal 4 because this is a quartic function. So, starting off with the positives, I could have 2 or I could have 0. If I have 2 positives, I could also have 2 negatives, which means nothing is left over for the imaginary. If I have 2 positives, I could have 0 negatives, which means I could have 2 imaginary solutions. If I have 0 positives, that means I could have 2 negatives, and that means I would have 2 imaginaries. Or I can have 0 of both. The whole thing be imaginary, which means I'm left with 4 imaginary solutions. So listing my solutions, I could have 4, 2, or no imaginary solutions. Technically speaking, these are the answers to the question. It wants to know the list. How many solutions? Well, I could have 2 over 0, 2 over 0, 4, 2 or 0. I accepted the chart for the quiz because I wanted you to at least show me you knew how to use the chart. For question 7, p of x, oops, not negative yet, negative x to the 5th plus 2x to the 4th plus 3x squared minus 7x minus 12. All right, looking at the sign changes when we have positive x, so just the positive possibilities right now, negative to positive, that's a change. Positive to positive, positive to negative, that's a change. And negative to negative. So I have 2 sign changes, which means I have 2 possibilities for positive real solutions, or counting down by 2, I could also have 0. Now we're going to substitute in our negative x. So now I have the opposite of negative x to the 5th plus 2 times negative x to the 4th plus 3 times negative x squared minus 7 times negative x minus 12. Simplify this out. Negative base, odd exponent. That means I'm going to have the opposite of what it was. So this becomes positive x to the 5th. Negative base, even exponent means it stays the same. Negative base, even exponent stays the same. Negative 7 times negative x would be positive 7x minus 12. So now, positive to positive, positive to positive, positive to positive, positive to negative. I have 1 sign change. So that means I have a negative solution. There's no possibility about it. One of my 5 solutions is negative. I can't count down by 2 because that means I end up with negative 1, and I'm counting. These numbers here are counting numbers. We don't count negatively. We're just looking at positive counting numbers. So I only have 1 possibility for negative solutions. So now when I am building my chart here, let's give me some space here. See how much easier it is when you have a pencil eraser? Go back to the pen. There we go. Take a pencil sometimes. We set up our chart, and this time we want a total of 5 because this is to the 5th degree up here. My only possibilities are 2 and 0 for positive and 1 for my negatives. So what that gives me is, for the first possibility, I have 2 positives, 1 negative. It means I have 2 left over of my 5 solutions. For the second possibility, I could have 0 positives, but I'm still going to have 1 negative. That means I now have 4 left over for my imaginary solutions, giving me 5 solutions. And what this is talking about, again, these real numbers tell me x-intercepts. So I could have 3 x-intercepts, or I could have just 1 x-intercept. So when I'm graphing this function, that's what I'm looking for. Speaking of graphing our functions, let's go ahead and move it over to the next page. But because this might take a little bit of time, and I don't want to put question 10 all by its lonesome, I'm going to go ahead and stop the recording now and actually go ahead and do a 3rd recording. So let's cancel out of this, and I'll see you on the 3rd side.